好啦，因為疫情嚴重咧，唔知幾時先開學，所以咧而家只好喺呢度同大家做 exam correction 啦。咁大家呢排都乖乖地留喺屋企做 past paper 啦。咁我哋就揾咗幾題特別多人錯嘅講下呢個 correction。咁咧其實呢題第三題咧就好簡單啦。Paper one question number three. So a ball of weight 300 Newton is inside a lift which is falling freely. Okay, so the force acting on the ball by the floor of the lift will be. So first you need to draw the free body diagrams. Okay, so there is a lift and a ball is inside the lift which is falling freely. Okay, so if the ball is falling freely, that means the acceleration equals to the gravitational field strength, which is 9.81 meter per second squared. Okay, so the net force equals to the weight minus normal reactions of the lift. Okay, so there are two forces acting on this ball. The first one is the normal reaction, the second one is mg. However, we know that F equals to ma, right? And now we know that A equals to g. The acceleration equals to the gravitational field strength. So we arrange the equations, then we know that the normal reactions is actually equals to 0. So it's easy to understand, right? If you're falling free, of course there is nothing supporting you. If not, you won't be fall freely. Okay, so your accelerations will be lower than 9.81. So the second one, which of the following is not properties of stationary wave? So particles at north are always stationary. So first we can draw a simple stationary wave. So these are the stationary waves, and the red dot are the positions of the knot. Okay, so the knot would not move during the wave transfer, and then the particles between two successive knots are in phase. Okay, so the particles between two successive knots, of course they are in phase because they reach the maximum displacement at the same time. Okay, so that they are in phase. It's not a property, so this is a property. So this is the correct property. So different particles may have different amplitude. So it's correct because it's a stationary wave. For example, the particles here have the amplitude which is largest, okay, and larger than the other two. So different particles may have different frequencies. So this is wrong because they are actually on the same standing wave. So they have the same frequency. The answer is D. So this one is A. And then the diagram shows the light spectrum produced by a particular element as viewed in the laboratory. Okay, so this is the spectrum we can call standard. Okay, so because we record it on the surface of Earth, so a star containing the element which is moving away. Okay, so according to the Doppler effect, so when the star is moving away, then the frequency will be decreased, okay, and the lambda will be increased. So in this case, we call this redshift. So the light spectrum from the star actually having the redshift. So what's the meaning of shift? Okay, so this part will move to the red end. Okay, so but the intervals between two lines doesn't change. Okay, so you can imagine that we move this whole pattern toward the left hand side. Okay, so for a little bit, so we can compare it these four diagrams. So letter A, so the intervals change, so it's wrong. So it's same for letter B, and for letter C is what we call blue shift. Okay, so because the lines are moving toward the violet end, so it's wrong again, and only D is the correct answer. Okay, so those lines move toward the red end together, and so almost more than half of you got the wrong answer in this question. Okay, so we have three parameters for us to calculate the density. Okay, so density equals to density equals to mass over volume equals to mass over volume. So actually you use both these three parameters, and then among these three parameters, the diameter has the smaller numbers of significant figures. There are only two significant figures, right? So the volume should have two significant figures. So 2SF should be given. So in this case, if you convert this number into 2SF, then you just keep the first two, right? And then it is 5 for the first decimal for the first number. Okay, so your answer will be 9.0. Okay, so because you can only show 2SF for this question. And then so a ball is dropped from a height 1.3 meters. So the graph shows how the height above the ground varies with time for several bounces. Okay, so the ball is dropped, and this diagram is actually the displacement times graph. Okay, so how can you get the velocity times graph from the displacement times graph? So get the slope. Okay, so what is the slope of this graph when time equals to 0? It's 0, right? 0, 0, 0, 0. So you got few 0 point here, and since you drop the ball from a certain height, right? And then the acceleration should be a constant. Okay, so equals to negative 9.81 meter per second squared. Okay, so the acceleration is a constant. Oh, it's very difficult to write here. Acceleration is a constant. So what is acceleration? Acceleration is the slope of the velocity times graph. Acceleration is the slope of the velocity times graph. Okay, that means the slope of the velocity times graph should be a constant. The slope of the velocity times graph should be a constant. So only letter 8 fulfill this condition. Okay, so why not C? Okay, so it seems that for C the slope is also constant, right? But the slope for graph C is 0. Okay, so which means the acceleration should be 0 meter per second squared. Of course, it won't be the case because we drop a ball from the height. Okay, so we can't choose C. And then for B and D, the slope are not constant. They are not constant, so the accelerations won't be constant. So the only possible choice will be A. And then so one side of the mountain slope at 25 degree, the other is 35 degree. So 25, 35. Okay, so someone is climbing to the top to collect the rock samples. Okay, so by discussing the breakdown and the forces involved, explain which would be the easiest side to climb to the top. Okay, so think about if you're the guy which is climbing to the top. Okay, so of course this end will be this side will be more difficult for you to count. Okay, because the slope is much higher compared to the other side, right? So if we draw the free body diagram, okay, so only focus on this part. So what is the force you need to overcome if you try to climb up to the mountain from this side? Okay, so draw the free body diagram. So the forces acting on this guy is mg, so the second one should be the normal reaction, and then the driving force for this guy to came to the top. Okay. Wait. So if we ignore the friction or the air resistance, then there are only three forces. And if you draw the coordinate along the slope, oh sorry, it's terrible. So here is 35 degree. So what is the component of the weight which against the directions of your driving force? So the force drawing you down is the component of mg, okay, so which is mg psi 35. Okay, so this is the force which the weight draws you down the slope. So your driving force should be at least equals to this component. So for the right hand side, the force need to be higher than mg psi 35. So for the left hand side, the force need to be higher than mg psi 25. So as you can see, so psi 35 is larger than psi 25. So you need to have a higher driving force for you to move to the right hand side. Okay, sorry, I just clicked this button. So now we can't go back, but I think you have the concept. Okay, so I draw the diagram first. Okay, so this one has a higher slope. So you need to apply more higher driving force in order to come to the top rather than this side. Okay, so from the perspective of applying force, so this side is more difficult for you to come up. However, what's the work done or the energy consumed? So for the work done, so we only need to care about mgh. Okay, so the h is the displacement along the y-axis. So it's not related to the side you choose. Okay, so no matter which side you choose, you need to go to the top, right? So the vertical displacement will be h. So the work done you need to apply will be the same. So the work done you need to apply will be the same. Why? Okay, so you can go back and to see the answer. Okay, so if you still can't understand because I don't know which button I touch, so we go to question number 4 now. So this is the standard projectile motion. So actually, most of you got the correct answer, but I need to mention something. So what is the speed of the vortex at point Q? Okay, so it reached the highest point, right? But many of you gave me the answer that the velocity should be equals to 0. But it's wrong. Why? Because Vy equals to 0 only, but not Vx. Okay, so Vx equals to the initial velocity times cosine theta. So the velocity along the x-axis doesn't change, only Vy equals to 0. So the speed of the vortex at point Q is actually equals to Vx. Okay, so because the y component is 0. And what is the acceleration? So it's negative 9.81. So find the velocity of the vortex just before it hits the ground. If it is from 2 meters above from the ground. Okay, so 2 meters. So for you to answer this question, then you need to know the velocity of along y-axis and the velocity along x-axis. Okay, so the velocity along above the ground. So you need to draw the ball here. So when it reach the ground, then you need to know the velocity along x-axis and the velocity along y-axis. So you already know the velocity along x-axis, which is the velocity along x-axis is v cosine theta. and you need to know the velocity along the y-axis. Okay, so you need to know the time for this object to reach the ground, and then to use v equals to uy plus gt. Okay, so first we need to find the time. Okay, so find the positive direction. Okay, so let's assume that the positive directions will be upward. Okay, then the times needed can be applied this equation. So S equals to UT plus 1/2 GT squared. Okay, so don't forget we assume upward as the positive direction. So the displacement is now becomes -2 because you are going down. Okay, so the initial velocity is V psi theta t. Okay, so plus 1/2 GT squared. Okay, so -10. You should write -9.81, but I don't know. I don't want to write so many numbers. So and then t squared. Okay, so once you solve the t, then you can use Vy equals to Uy plus GT. Okay, then you can find the final velocity of y, or you can use these equations directly. So Vy square equals to uy square plus 2as. Then you can solve Vy directly. Okay, and here is the final velocity. So for the final velocity, just use the Pythagoras theorem to solve it, and don't forget to give the angle. Okay, so for example, if I assume this angle to be alpha, then tangent alpha equals to Vx Vy. Okay, so you are asked to find the velocity, and the velocity is a factor, so you need to give the directions and the values as well. Okay, so I think you can solve these questions on your own. Okay, so let's see question number 9. So a student investigates how the length of a spring varies with force by handing masses on it. The graph shows the result. So the student concludes that the spring does not obey Hooke's law because the line does not pass through the origin. So explain why this conclusion is correct. So incorrect, sorry. So it seems that the student is correct, right? So because F equals to K delta X, so if the spring obey Hooke's law is supposed to be passed through the origin. However, so let's see this diagram. The y-axis is not delta x here. The y-axis is just the length. Okay, so even she doesn't pass through the origin, it still obey the Hooke's law, because even you don't apply any force, there will be length for the spring, right? 你唔會唔擺力落去，條彈弓就變咗冇長度啊嘛。好啦，咁所以呢個同學就唔啱啦。Show that the spring constant is about 30 newtons per meter. So what can we do? So it seems that it's not a standard diagram for the Hooke's laws. But actually, what we need to know is delta length. Okay, so what is delta length? The change in length is actually delta x, right? K equals to F over delta x. So what we need to know is just the force, which is the y-axis, and the delta x. Okay, so delta x can use this point to minus this point. So actually, the spring's constant is 1 over slope in this diagram. Okay, so the spring's constant is F over delta x. Okay, so the spring's constant is F over delta x, so which is 1 over delta x over F. 1 over delta x over F. Okay, so delta x over F is the slope on the diagram. So the spring's constant is 1 over slope. Okay, sorry about that. I misclicked again. So you move to C and D. And later I will show you the answer that you can see the mark scheme. Okay, so I think C and D are more difficult. So when the student is removing the masses, the spring is accidentally released when its length is 23 meters. So the spring flies up into the air. So that's the energy story. In the spring is about 0.68 when its length is 23 centimeters. So for you to find the energy, then you can use 1/2 k square or F delta X, and you can go back to the previous page to see the energy story. Okay, so the triangle here. So the triangle here. Wait. Okay, so find the area of the triangle, then you can find the energy storage. So to calculate the maximum height, so the energy equals to mgh, then you can find the maximum height. Okay, so what I want to tell you is letter D. So several other students carried out similar investigations using identical springs. So the photograph shows some of the springs at the end of the investigation. So on the essence about sketch for spring C and use it to help you describe the differences in the behavior of spring A and C. Okay. So for spring C, even you remove the force, there will be the change in length, right? So the original length of the spring is like the spring A. So this is the original length. However, for C, even you remove the force, then there may be some extension. Okay, so there will be delta X here. Even you remove the force suddenly because it's already passes through the U point or the elastic limit. Okay, so it can't go back to its original shape. So here are the answers. So use 1/2 k squared and the energy equals to mgh. And then for this question, even you remove the force, then there will be some extension. Okay, so because can't go back to its original shape. Okay, so let's go to exam paper 2. So there are not many difficult questions for exam paper. Okay, so now let's go to question number 5. Beam of identical positive ions so travels horizontally in a vacuum. So the ion pass through two charged plates and are deflected downward by the electric field between the plates. So the diagram shows the path of one of the ions. So explain the path of the ion between the plates and when it has left the plates. So when the ion is moving between the plates, and it is a projectile motion. Okay, so because the horizontal velocity doesn't change, it won't be affected by the electric field. However, for the y-axis, okay, so for the y-axis there is accelerations because for the y-axis the force F equals to QE equals to ma, so there is accelerations for the y-axis, but no accelerations for the x-axis. So in this case, it's same to the projectiles under gravity. Okay. So when it has left the plate, can you see that the trajectory of the ions becomes a straight line because there is no more force, right? So no more acceleration. So due to Newton's first law, then you will have a strict motion. So the electric field is still acting. The path of the ions can be returned to horizontal by applying the magnetic field over the same regions as the electric field. So we know that the electric force is pointing downward. So if we can apply a magnetic force which is pointing upward, QEB, then we can balance this force and make the ions to move horizontally. Okay, so this is actually the principle of the velocity selector. So all we need to do is to apply the magnetic field, which will make the magnetic force equals to the electric force. So explain the explain the conditions under which the ions have no overall deflections as they pass between the plates. Okay, so here is the condition. So QVB equals to QE. Okay, so the ions have a velocity of 260 km per second, so the plate separation is 4.5 centimeter, and the potential differences across the plate is 60. We calculate the magnetic flux density. Magnetic flux density is B required so that there is no overall diffractions of the ions. State and explain how the path of the ions in just the magnetic field would be different from the path in just the electric field. Okay, so first let's do this question. Since we know that QEB equals to QE, we know that QEB equals to QE. We know that QEB equals to QE. QEB equals to QE, and then use V equals to E. V equals to E times D. Okay, so E equals to V over D, then you can solve this. Okay, so I misclick again, so we will see that directly. If there is no electric field or no magnetic fields, what are the differences between them? So the outbreak path or the magnetic path is an arc of a circle. Okay, so for the charged particles inside the magnetic field, there is a uniform circular motion. However, for the electric field, then it may be a parabola or the trajectory like the projectile motion. Okay, so here are the differences you can think of. And then, so the last questions I would like to do the corrections with you. So I think most of you know the physical meaning here. So what I wanna to explain is the first two questions. So what's meant by the relativistics? So the velocity is moving at a very, very high speed, which is close to the speed of light. So the second one state why it is necessary to use very high energies in experiments such as this. Okay, so you need to overcome the repulsion between the nucleus. Okay, so if you want to have the collisions, then you need to overcome the repulsion. And for the calculations, I will just show you the answer. Since the mass of helium is 4U, okay, so and then apply E equals to delta MC squared, and you can solve the mass. Okay, so and then to convert the unit. And here, what I wanna share with you about the exam corrections. 好啦，咁大家身體健康，快啲做 past paper。特別係考4校聯考嗰啲，哇！你可能一開學就到啦。OK， 同埋 GC 嗰啲快啲做 past paper。咁咧，我 send 咗 answer 俾你啊，你可以自己對。如果你唔明咧，你就問，千祈唔好唔做。千祈唔好唔做。